Good morning and welcome to Cooking with Andrew. Here we have a delicious yellow cake batter. Come take a look. Come take a look at this. Doesn't that just smell fantastic? I wish you had smell-o-vision. Now, the amazing, you know what this makes me think about? This makes me think of the plum pudding model in chemistry. You know, like where all the elements are humble-jumbled together. That's what this makes me think of. Alright, random thought. Now let's get this in the pan. You know, pouring this cake batter into this pan really reminds me of Rutherford's solar system model, which was a little bit more organized than the previous plum pudding model. It consisted of a high energy center in a very small volume. This cook cake reminds me of Bohr's model. It's even more organized. We finally have different electrons circling around the nucleus. We're going to add some different flavor to the cake by adding some icing. Just like Schrodinger's atomic model with different sublevels added a different flavor to the atomic model. Thank you for watching Cooking with Andrew. Hey! I'm Andrew from Dixon and Andrew in the Morning. We'd like to remind you that you should check out our holiday special coming up later in December. Hello, and welcome to Chemistry 360. I'm Andrew Shoemate. I'm here with a quantum number. Hello, quantum number.
Hello.
Quantum number, tell me, what is it that you do for a living?
Well, first of all, I tell everyone what parts of elements they have. I explain the energy level, the sublevel, the orbital, and the spin of any element.
Fascinating, truly fascinating. And tell me more about this energy level. How do you find that?
To find the energy level, you look at these numbers along the side. These numbers are the energy level.
Wonderful, wonderful. And the sublevel thing you mentioned, tell us more about that, please.
Well, there are 4 different sublevels. First we have S, and then we have P, and then D, and then F. The different sublevels have different shapes.
And the orbitals, is that connected to the sublevel?
Yeah. You find an orbital by where it is on the periodic table.
And then lastly, the spin you mentioned. Tell us more about the spin.
Well, it's either negative or positive, and it goes negative, positive, negative, positive, negative, positive, and you only find it by where it is on the periodic table.
Amazing. Quantum number, it's been a joy having you on the show. Thank you for coming.
You're welcome.
Hello. Breaking news story. The Quantum Hotel is burning to the ground.
All sublevels in this building, including the energy levels, are being destroyed.
Truly tragic. Truly tragic. Another, just to add to the tragedy, Mr. Quantum, who just appeared on Chemistry 360, he's in the ICU. He has fallen out of the building, but he wasn't the only thing that has fallen. The sign on top of the building, it fell spinning towards the ground. One eyewitness had to say, it fell spinning like an electron. Truly, truly terrifying, terrifying. The whole electrical configuration of the building has been disrupted and changed. Authorities are trying to correct that, but it's probably too late. The building shape itself, terrible. The shape of the building is just awful. Totally been destroyed. We'll be following the story very closely.
Now we'll be returning to Chemistry 360. Hello, it's Chemistry 360, and I'm back with electron configuration.
Hey, how you doing? All right, well, here, let me tell you a little bit about electron configuration. First number we have here, this is the energy level, and we can have 1, 2, 3, all the way up, depending on what row you're on the periodic table. Next, we have the sublevel, and that's represented by this letter here. And we already talked about our sublevels. We have S, P, D, and F. So that's our sublevel. And right here, we have the number of electrons found in that particular sublevel. So in 3p, we have 6 electrons.
Now on Chemistry 360, we are interviewing electron configuration's odd cousin.
A.
Orbital notation.
I'm orbital. All right. Orbital notation. S sublevels have 1 orbital, represented by 1 circle here. We have 2 electrons. Now you can have 2 electrons per orbital. So we represent those by a dash through the orbital, and we do that. P's have 3, and D's have 5. F's would have 7, but there's none. There's no F's in zinc. I don't know. Anyway, so to fill all 5 of these d sublevel orbitals, we need 10 electrons, which we have. So we are able to dash through all of those. So we have a full orbital notation.